What is corrosion? Corrosion means the degradation of metals, right? Now, many think corrosion means rusting. Rusting is an example of corrosion. It is not specifically only, rusting is not the only example of corrosion. It's one of the example. Now, degradation of metal other than iron can be copper as well by gases and water vapor due to the formation of oxides with oxygen, carbonates with CO2, with H2S, sulfides, all these formation. It is known as corrosion. That is the degradation of the metal. We have seen that rusting of iron is one such example. Degradation of copper is another example. Basic copper carbonate formation. During the degradation, it gives a greenish color over copper. Now, this is an important question that is asked in most of the exams. Rusting of iron, do you believe it to be an electrochemical process? You have to justify your answer. Obviously, if it is an electrochemical process, that means there should be a redox reaction occurring. Somewhere there should be an oxidation and somewhere there should be reduction occurring. What happens is the impure surface where we can see the rusting has already started. That is the impure substance of iron that behaves like an electrochemical cell. And this impure surface reacts with moisture, reacts with CO2 from atmosphere. And such a cell that behaves in this manner, that reacts in an oxidation and reduction manner, is known as corrosion cell. That is, it is behaving like an electrochemical cell and the process that is going on is corrosion. So it is a corrosion cell. Now, what reaction is actually taking place here? At anode, see, if it is an electrochemical cell, there should be oxidation taking place. And what happens over here is the pure iron acts as anode. The iron which is still pure, which did not undergo rusting, is acting as the anode, and that loses electron and gets oxidized. This electron is gained by the impure surface of iron, which acts as the cathode, and there occurs gain of electron. This is how I was showing how this is taking place. So let's see. Electrolyte is what? Electrolyte is the moisture. So there are certain requirements of rusting. It takes place in the presence of moisture. It takes place in the presence of oxygen. Yes, so moisture with dissolved gases like CO2, like O2, that acts as the electrolyte. And what is the anode reaction taking place? That is oxidation reaction taking place. Just now we said the pure surface is acting as the anode and undergoes oxidation. So Fe is undergoing oxidation to produce Fe2 plus with a reduction potential of minus 0.44 volt. And what reaction is taking place at cathode? Reduction takes place. The electrons that are liberated here, they are carried to this region where the H plus ions present by the dissociation of H2CO3 abstracts the electron in presence of oxygen. Now let me explain this part. See, the moisture that is present above the iron surface, the water droplet suppose that is present above the iron surface. Now if this is the pure iron part, this is acting as anode, right? And then the iron which is there is oxidizing, losing 2 electron, forming Fe2 plus, loses 2 electron. Now this 2 electron which is lost, it travels to this part. Now it travels to the part where rusting has started. So say this is the impure iron and it is acting as the cathode. And this moisture in the air there is CO2, there is O2, and it is dissolved in this H2O. CO2 is also going inside, O2 is also going inside. Now this H2O reacts with the CO2 and it forms what? H2CO3. This forms H2CO3. This H2CO3 will dissociate and will give twice H plus and CO3 2 minus, and the O2 is already dissolved inside. So this electron, twice electron, is taken by the H plus, is taken by O2 and it forms H2O. See the reduction potential. So it gets immensely reduced very fast because it has a value of plus 1.23 volt. So this is what is taking place here, right? So hence it is a redox reaction. It is an electrochemical process and the overall cell reaction is Fe forming Fe2 plus twice H plus in presence of half O2 gives you H2O, and this is the E0 cell for the overall reaction. Now the Fe2 plus thus formed will further get oxidized in presence of atmospheric oxygen to give higher oxides. So twice Fe2 plus half O2 plus 2H2O forms Fe2O3 and 4H plus. This Fe2O3 reacts with XH2O and it forms rust, which is hydrated ferric oxide. Now this rusting can be prevented by methods like galvanization, which is the giving a coating of zinc over iron, where zinc will preferentially get oxidized and it will form Zn2 plus because it gets oxidized in preference to iron. And another method is sacrificial protection. Well, let me tell you, galvanization is again a sacrificial protection where zinc is undergoing sacrifice and getting oxidized before iron. And another sacrificial method is the electric protection, which is seen while preventing the rusting of underground water pipes, the iron pipes. This acts as cathode, and it is actually connected to an anode plate of a reactive metal, say magnesium, which has a greater tendency to get oxidized than iron, and it loses 2 electrons and forms Mg2 plus. These 2 electrons are taken in this reaction and forms H2O. Right. So this is again how the underwater pipes are prevented from rusting by the electric protection method. Now, methods of preventing corrosion, we have barrier protection. Greasing is a barrier. It actually is, grease is applied to the surface, and so the surface of iron is directly not in contact with the moisture present in the air, with oxygen present in the air. Another method is electroplating with metals like nickel, chromium, copper, gold, silver. These, where a coating of these metals are used, done using electric current. And here again, the cathode is the negative terminal. Here it is electroplating. So the cathode is negative terminal and the object that is to be plated, that is the cathode, and the anode is the positive terminal where the metal to be coated with, that is the anode. And electrolyte is the solution of coating metal, that is the electrolyte. So these are the methods by which corrosion or rusting can be prevented.